Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solution of a mathematics question that was asked in one of the shifts of JEE Main 2025 January session exam. This question is based on the topic of definite integration. It says if 24 into integral 0 to pi by 4 sine of mod of 4x minus pi upon 12 plus GIF of 2 sine x dx equal to 2 pi plus alpha, where GIF stands for the greatest integer function, then alpha is equal to. Now students, basically in this integral, we have to find its value and then by comparison, we have to get the value of alpha. Now first of all, I will break this integral into two parts as 24 into integral 0 to pi by 4 sine of mod of 4x minus pi upon 12 dx plus 24 into integral 0 to pi by 4 GIF of 2 sine x dx. Now students, the first integral we will break as per the modulus function and the second function we will break as per the greatest integer function. Now we know that mod of x is equal to x when x is greater than or equal to 0 and mod of x is equal to minus x when x is less than 0. So this clearly means that mod of 4x minus pi upon 12 will be equal to 4x minus pi upon 12 when 4x minus pi upon 12 is greater than or equal to 0. That means when x is greater than or equal to pi upon 48, then mod of 4x minus pi upon 12 will become equal to 4x minus pi upon 12, right? And when x is greater than 0 but less than pi upon 48, then mod of 4x minus pi upon 12 will be equal to minus inside the bracket 4x minus pi upon 12. We also know that sine of minus theta is equal to minus theta. So that means when x lies between 0 to pi upon 48, then sine of mod of 4x minus pi upon 12 will become equal to minus sine of 4x minus pi upon 12. Now students, we move further. Now students, the first integral is 24 into integral 0 to pi by 4 sine of mod of 4x minus pi upon 12. Now it is very much clear from the previous discussion that we have to break this integral at x equal to pi upon 48, because when x is greater than 0 and less than pi upon 48, then sine of mod of 4x minus pi upon 12 is equal to minus sine of 4x minus pi upon 12. And when x is greater than or equal to pi upon 48 and less than pi by 4, then sine of mod of 4x minus pi upon 12 is just equal to sine of 4x minus pi upon 12. So that means now I can write this integral as 24 times. I am breaking this integral into the sum of two integrals. Inside the bracket, we will have the first integral as integral 0 to pi upon 48 minus sine of 4x minus pi upon 12 dx, and plus the second integral is integral from pi upon 48 to pi upon 4 sine of 4x minus pi upon 12. Now students, we will find the values of both of these integrals. Now this becomes 24 times. Now integral of minus sine of 4x minus pi upon 12 is cos of 4x minus pi upon 12 divided upon 4. And this value is under the limits 0 to pi upon 48. And then we have minus cos of 4x minus pi upon 12 divided upon 4, and this value is under the limits pi upon 48 to pi upon 4. Now students, we move further. Now students, it further becomes equal to 24 into inside the bracket. Now we will put x equal to pi upon 48 in the first expression. So it becomes cos of pi by 12 minus pi by 12, which is nothing but cos 0, and that is 1, minus, now we will put x as 0 in the first expression. So it becomes cos of minus pi by 12, which is same as cos of pi by 12, whole divided upon 4. Then we have minus. Now inside the bracket, we will put x as pi by 4 in the second expression. So it becomes cos of pi minus pi by 12, which is minus cos pi by 12, minus, now we will put x as pi upon 48 in the second expression. So it becomes cos of pi by 12 minus pi by 12, which is again cos of 0, and that is 1, whole divided upon 4. Bracket close. Now students, this further becomes equal to 24 times. Inside the bracket, the LCM of the denominators comes as 4, and in the numerator we have 1 minus cos pi by 12 plus 1 plus cos pi by 12. Now clearly cos pi by 12 and minus cos pi by 12, they get cancelled, and we get 24 into 1 upon 2, which is just equal to 12. Now students, we will find the value of the second integral, and that is 24 into integral 0 to pi by 4 GIF of 2 sin x dx. Now students, when x lies between 0 to pi by 4, then sin x lies between 0 to 1 upon root 2. So clearly 2 sin x will lie between 0 to root 2. And we know that GIF function gets broken at all integral inputs. That means whenever the input of the greatest integer function becomes an integer, then for that value of x, the greatest integer function gets broken. Now between 0 and root 2, one such integral value is 1. That means when 2 sin x becomes equal to 1, or sin x becomes equal to 1 upon 2, or x becomes equal to pi by 6, then this integral will get broken. So clearly when x is greater than 0 and less than pi by 6, then the value of GIF of 2 sin x will be equal to just 0, because in this interval 2 sin x will lie between 0 to 1. And when x is greater than or equal to pi by 6 and less than pi by 4, then in this interval the value of GIF of 2 sin x will be equal to 1. Now students, we move further. Now students, This integral can further be written as 24 times inside the bracket. Now we will break this integral into two parts. The first integral is from 0 to pi by 6 GIF of 2 sin x. Now students, we know that when x lies between 0 to pi by 6, then the value of GIF of 2 sin x is just 0. So this becomes 0 dx plus the second integral is from pi by 6 to pi by 4. And here the value of GIF of 2 sin x is 1. So it becomes 1 dx. Now students, this further becomes equal to 24 times inside the bracket 0 plus the integral of 1 with respect to x is x. So the value of the second part becomes pi by 4 minus pi by 6. And this is further equal to 24 into pi upon 12 or equal to 2 pi. Now students, the value of the required integral becomes 2 pi plus 12. And this is given to us equal to 2 pi plus alpha. So that means the value of alpha is equal to 12. So this is the right answer of the question. Now students, in my next video, I will discuss the solution of another question from JEE Main 2025 January session exam. So keep watching my videos and enhance your knowledge of mathematics. Thanks.